The solar system. Yeah, because that's what I decided to do. So what's up? If you want to know why I'm uploading a video about the solar system, if you're one of my subscribers, it's because I have a science project due in 5 hours. Yeah, I'm pretty bad at time management. I know. Shut up. Anyways, back on topic. Solar system, right? You all know it. Planets, the sun, debris, belts of random space stuff, whatever, meteors. You already know it. Learned that in like fourth grade, third grade. I don't need to explain all that. But the way it was started, kind of a big deal. So you know the Big Bang Theory. We all know of it. And no, I'm not talking about that one show. Though it is a pretty good show. And so is Young Sheldon. No sponsors. But the Big Bang Theory is the most widely accepted explanation for how the universe came to be. Apparently, it began as an infinitely small, hot, dense point, which then basically blew up and expanded and stretched out for over 13.7 billion years. That was like before the dinosaurs or something like that, I don't know. But this theory has a lot of evidence supporting it, including the cosmic microwave background. I don't know why it's called that. Something to do with a microwave, I guess, but some scientist thing that they came up with, one of the theories that helped with the Big Bang. But the theory has a lot of mathematical explanations backing it up. But it genuinely can't be fully solved because they haven't fully figured it out yet. It's just a whole bunch of math. And of course, they just haven't figured it out. I don't know. I mean, they need to like hurry up because it's been a couple years now. But I kind of believe in it. I don't know if y'all do, but it just seems kind of crazy how it just kind of blew up and then bam, space happened, whole solar system, universes, and all that. But anyways, so that whole Big Bang thing happened, and spreading matter and radiation all through this void happened in a literal matter of seconds. This whole mix of neutrons, electrons, protons, atoms, all that stuff. It was everywhere and it was super, super hot. 5.5 billion degrees Celsius. That's a lot. It's almost as hot as you. Not really. You're chopped. So then, we finally get those electrons, and everything started coming together and finally let light shine through. 380,000 years after the Big Bang. I don't know why this stuff took so long. I'm literally so impatient waiting for my pizza rolls to get out of the microwave. How the universe be waiting this long? I don't know. But anyways, that part there was called the afterglow of the Big Bang Theory. And that discovery was actually an accident made by scientists. I don't know how it's an accident. I guess they were just doing math and they're like, wait a minute, this happened? Wow. Yeah, I have no clue. Oh yeah, I'm congested by the way. I'm sick. So, planets, the big ones, the sun. A group of protostars start to form from a cloud of debris left by prior star explosions after galaxies like the Milky Way start forming 4.6 billion years ago. Then, these protostars have a lucky contestant, the big old sun. Big old sun, shine brighter than any of them out there. Get it? These giant planets, Jupiter, Saturn, Uranus, Neptune, all of them, form around this protosun. And Uranus and Neptune had formed a lot closer to the sun than where they were today. And possible one or more ice giants may have also formed, but then they were later ejected from the solar system. They weren't cut out to be there. They kicked them out. The sun had then began fusing hydrogen and helium. That was 4.55 billion years ago, and so a little while ago. That was quite a bit. So now Mercury, Venus, and Earth and Mars formed from more debris around our solar system, and apparently a Mars-sized planet that used to be around the sun as well had collided with Earth, and that debris had formed the moon. Now, 4.5 to 4.1 billion years ago, the sun gravitationally separates from those other protostars, and the giant planet's orbits shifted with it, scattering small planets through the solar system. Some bombard the inner planets and likely delivered water and organics to Earth. Ending off that 4.1, 3.8 billion years ago, entering into 4 to 3 billion years ago, that small planet bombardment caused widespread volcanoes on the inner Earths. Not inner Earths, inner planets. While these volcanoes were happening, life had finally begun on Earth. Mars also starts losing most of its atmosphere and water. Water. Imagine Mars with water. Crazy. Pour some water on it. But anyways, now, 2.5 billion years ago, photosynthetic organisms evolve on Earth and start pumping oxygen into the atmosphere, helping create the blend of gases we breathe today. Then finally, volcanism on the moon had stopped 1 billion years ago. Fast forward a little bit, 100 million years ago, fast forward a little bit, 100 million years ago, an impact on the moon forms the tidal crater on it, and Saturn finally gets its rings. Anyways, the tidal crater, the most prominent craters on the moon, basically a bright spot in the southern highlands, with rays of bright material stretching across much of the near side. It was pretty cool. It's really bright, actually. I'll show a picture of it. That was 100 million years ago, and then 35 million years later, you have the extinction of the dinosaurs. Crazy event that happened. Low-key, Fortnite event right there. Then you get to now, the solar system we all know of. The calm, beautiful looking place. Pretty cool. Yeah, I thought that too. I love the solar system. Until I had to make this YouTube video for a science project. But yeah, anyways, subscribe to me because this took a while to make. Hit the like, Miss Almond. Yeah, I know you watching this. Hit the like button. Don't just close out the tab. Hit the like button. Thanks for watching. I appreciate it. This is gonna suck to edit, but I'm going to sleep now. Good night.